Welcome back to sections 17.1 and 17.4. In this video, we'll be going over example 2. So example 2 is on the screen, and it's asking us to find the mass moment of inertia of this pendulum. So it's been redrawn over here. So we basically can model this as a pair of slender bars connected, and the mass, the center of gravity is found from this datum up here with this dimension y bar. So the first thing we want to do to solve this problem is find y bar. So if you remember back to statics, y bar is equal to the sum of the partial y bars times the mass over the sum of all the mass. And so we can do this with weight instead of mass so that we save ourselves a little bit of work because the units will cancel out. So we're just going to say that this is the sum of the partial y bars times weight over the sum of the weight. All right, so we have two bars. We have bar BC and bar OA. So for the first bar, bar OA, it's y bar. And so notice that everything is going to be measured from this datum going down. So if you want, I will indicate down positive. So OA is 2 foot long, which means its center is 1 foot from the datum. And it has a weight, we were given a weight of 10 pounds. Bar BC is all the way here at the bottom. Its center is here at A. And that center is 2 feet from the datum, and it has a weight of 8 pounds. The total weight is 10 plus 8. And there you will get, so when you solve this, you should get 26 over 18, which is approximately 1.444 repeating feet. So that's where y bar is located. So now we need to find IG, so the mass moment of inertia about that center of gravity. So let's do that for each of these bars. So I'm going to start with bar BC. And we're going to start off by finding it about the center here at A. So we're looking at just bar BC, and we're going to find I about point A here. So if we go back to our book real quick, there's a convenient equation for slender rods. So this is our slender rod equation down here. And so we want one that goes to the center of it, and that's going to be this x or y. If we go about the end point, it's x bar, y bar. We'll use that one for the next one. So xx and yy is 1/12 ml squared. So I'll write that down. All right. So therefore, all we have to do is plug in all of the numbers, and we will know I about A. So 1/12, the mass of this is going to be our 8 pounds divided by 32.2 for gravity. The length, it has a total length of 1.5 feet, and we can square that. Let me calculate that real quick. We'll be right back. All right, I'm back. So the answer is 0.04658. So that's the mass moment of inertia about A for bar BC. So let's go look at bar OA. So we could do it about its center, but for practice, I'm going to go about O. Also, the center is really close to G. It's not exactly G, so let's not confuse ourselves. So I'm just going to go at the top up here at O. So now we're looking at bar OA. We're going to find IO, so the mass moment of inertia about O. So just like we did with this one, we're going to find an equation. So it's not going to be 1/12 ml squared because we're not going about the center of the bar. We're going about the end point. So if you remember, so that's going to be x prime, y prime. And so x prime, y prime is 1/3 ml squared. And again, those are in the back of your book. Sorry that the document camera froze there. All right. So again, we'll just plug in all of our numbers. So our mass will be 10 divided by 32.2. In this case, our length is 2 feet. And we'll square that. And I'll be right back with that number. All right, and so it ends up being 0.4141. So now what we want to do is we would like to try to find IG, but we have mass moments of inertia at multiple different locations. So we want to find it here, and I found it here and here. So what I need to do is I need to combine my mass moment of inertia at A with my mass moment of inertia at O, so then I can use what's called parallel axis theorem to move them to G. We can't just simply add numbers up because this is about different points. So this works a lot like moments. So we have to be careful. It has to be about the same point before I can add them up. So that's kind of high level. What are we trying to do? So we want to find IO total, and that is going to be equal to IG total. This is what we want to find, the mass moment of inertia about IG, plus mass distance squared. So this function, or this formula, I naught equal to IG plus MD squared. This is parallel axis theorem, if you remember from statics. And this distance is the perpendicular distance between O and G. All right. So we need to first find this. So we find I total. We know that so we know the mass is the 18 pounds divided by 32.2. The distance is the 1.444 feet because Y and starts at O and goes down to G. So I already know both of these numbers, and I want to find this number. So the next thing to do is to find this, and we'll be in good shape. So in order to total up at O, so bar OA was already about O, so it's there. So I need to move this to O. So we do that with also using parallel axis theorem. So we're going to bring this back down. Bar BC. I about O. And so we're not going to rewrite 1/3 ml squared or anything like that. We're just going to take our number. So this is IG plus MD squared. So our IG was that 0.04658. The mass is the 8 pounds divided by 32.2. And then the distance is how far is the center of gravity from O. So it is 2 feet away. It doesn't matter if it's positive or negative because you square it. All right. And so that number should total up to be 1.0403. So 1.040 if we go to 4 sig figs. All right. So now we can find I total. So I naught total. Let me get that on the screen for you. So that would just be the two that we have already found, the 0.41 and the 1.04. We can just add them up because they are now the mass moment of inertia about the same point. So another strategy here would have been to find both of them about their center of gravities and then just move them straight to Y. That would also have worked. So you now get 1.454. And this is, the units on this is slug feet cubed. And so now we go back to this equation. So let me write this in red so that it stands out a little bit differently. Maybe my pen will work. All right. And we're basically done. So now we have our I naught total, which is 1.454, equal to our IG total, which is what we want to find, plus our mass. So our mass has a total mass of 18 pounds over 32.2. And then the distance was the Y bar that we found, which was 1.444 repeating, and that gets squared. So again, this is also parallel axis theorem. So the only thing we're left to find is this IG. When we solve this, we find that IG is 0.288. Slug feet cubed. All right, and if you have any questions, feel free to contact me.